Yes, Nana. So we were discussing alkenes, right? So alkenes, yesterday somewhat hybridization things we discussed. I gave the homework. Did you do those homework, right? Any doubts? Geometrical isomerism. I told you alkenes will show the geometrical isomerism. For example, AB, CD, if A is equals to B or C is equals to D, or that cases what happens now? In this case what happens? No GI, no geometrical isomerism, right? So when it is possible, if A is not equals to B and C is not equals to D, that cases it shows the geometrical isomerism. Write it down. The people who don't know, I told you cis and trans, right? Hydrogen, Cl, Cl, for example. This is what, Nana? Cis. So I already explained in geometrical isomerism. If anybody is missing, you can go back the geometrical isomerism part. You can just, I'm giving you a trailer, right? So I'm just outlines only I'm telling here. The detailed explanation of geometrical isomerism I explained in the isomerism topic. So if you miss, you can go and cross check over there. In our videos, in JN chemistry videos, it was there. In case of cis and trans cases, so which is having more boiling point? This is cis, this is trans. Which is having more boiling point? Cis case is dipole moment is not equals to 0. Whereas in this case dipole moment equals to 0 because both are opposite direction. I told you dipole moment is directly proportional to polarity. Dipole moment is directly proportional to boiling point. Dipole moment is directly proportional to boiling point. Now let me know which is having more boiling point? Cis. So dipole moment, cis greater than trans. Write it down. Polarity also cis greater than trans. Boiling point cis greater than trans. So only the melting point is trans greater than cis, because in opposite direction close packing structure is possible. So write it down. Dipole moment, polarity, boiling point and melting points. So no need to by heart. So dipole moment directly proportional to polarity, dipole moment is directly proportional to boiling point. This is cis or trans. So this is A and this is B, C, D, right? I told you if A is equals to B or C is equals to D, so no geometrical isomerism. It won't show the geometrical isomerism. No geometrical isomerism. Write it down. For example, try to understand. Hydrogen, chlorine, hydrogen. Is this cis or trans? Anyone? Is it shows the geometrical isomerism? It is A is equals to B. No geometrical isomerism. Chlorine, bromine, deuterium, hydrogen. Is it shows the geometrical isomerism? Is it showing the geometrical isomerism? Right? Hello. 1, 2, all are different groups, right? it shows geometrical isomerism, but not cis trans. We will go with EZ. So EZ cases what I told. So right side and left side we need to cross check according to CIP system, Kohn-Ingold Prelog system. If the Kohn-Ingold Prelog rules, first we need to see highest atomic number. If highest atomic number, so in these two cases, highest atomic number, both are same, but if atomic number is same, so then we will go with the atomic mass. So first, second, it is also, this is first, second. I told you, what I told, if it is cis type, one same, two same side, so then this is, we could say Z. If it is a like opposite direction, one, two, this is E. I already told you about this. And now, come on, just quick revision. Hydrogen, chlorine, fluorine, bromine. Come on, do E on Z, E or Z. Come and do it. So now I told you when small ring and big ring, which one will give the more priority? Small ring, right? 1, 2, 1, 2, right? Obviously that would be E, right? Here is, this is first, second, first, second. This is also E. Next here, 1, 2, 1, 2, Z, 1, 2, 1, 2, Z, 1, 2, 1, 2, Z, 1, 2, 1, 2, Z. Come on, write it down. So before counting of geometrical isomers, is this showing the geometrical isomerism? No? Hydrogen, chlorine, chlorine. Hello. So which one will show the geometrical isomerism, above one or below one? For example, if I am taking once again one more compound, which one will show the geometrical isomerism? Can you see this one, bro? Hello. How many double bonds here? Double bonds. I'm asking double bonds. 4. 4 means even or odd? Even. So always remember, whenever the even number of cumulative double bonds like this, even number of cumulative double bonds. So the terminal groups are perpendicular to each other. Now you can see, okay, this white is up, so this white is towards me. Yes or no? So means both are perpendicular. Whenever even number of double bonds like 2, 4, 6, 8, 10, dash, 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 no GI. Which double bonds? Cumulative double bonds. Cumulative double bonds. Why? Why no GI? Because the terminal groups are perpendicular like this. Is it clear, Nana? Is the structure is clear? Clear కనిపిస్తుందా? హలో. సో ఇప్పుడు ఇక్కడ ఈ బ్లూ కలర్ ఉంది కదా, ఇది ముందు సైడ్ ఉంది. దిస్ ఈజ్ అబౌవ్, దిస్ ఈజ్ దిస్ సైడ్. So this one won't show GI. This one also won't show GI. The green color is given the green. And I told one more important thing, Nana. Is this showing the geometrical isomerism? So which one will show the geometrical isomerism? A, B, C, D. Which one will show the geometrical isomerism? Right? Obviously, answer will be D. So minimum 8 carbon atoms are required for a cycloalkene to show geometrical isomerism. I already told you all these. So just for the revision purpose, which I am telling you. Minimum 8 number of carbon atoms are required because 8 member ring. Minimum 8 number of carbon atoms are required for a cycloalkane to show geometrical isomerism. Calculate the number of geometrical isomers for the following compounds. Write it down. Right. So first to solve these questions, we need to know its formulas, right? So for unsymmetrical case, hello. For to calculate the geometrical isomerism, for unsymmetrical one, unsymmetrical one, which formula we have to use? Unsymmetrical. To 2 power n. N means the double bonds which are showing the geometrical isomerism. Number of double bonds which are showing the geometrical isomerism. Next, symmetrical. Symmetrical, 2 power, in case of symmetrical both are there, even, 2 power n minus 1 plus 2 power n by 2 minus 1. In case of odd, 2 power n minus 1 plus 2 power n minus 1 by 2. Write the formulas. So complete geometrical isomerism. So already in our playlist it was there. In the live session also it was there. You can go back and watch those videos. First one. So this one it won't show because A is equals to B. Only 1, 2 power 1, 2. 2 power 1, 2. In this case, it's not symmetrical. It's unsymmetrical because it's only methyl ethyl group is this side. 2 power 2, 4. This one it won't show, right? This one will show. This one also. So do one thing, put one methyl group here to avoid the confusion. So 2 power 1, 2. Because it comes under symmetrical case. This is symmetrical. Right? Even. Symmetrical, even. 2 power 2 minus 1 plus 2 power 2 by 2 minus 1. 2 power 1 plus 2 by 2 minus 2 power 0 means 1. 3. This is symmetrical, odd. 2 power 3 minus 1 plus 2 power 3 minus 1 by 2. 2 power 2 plus 2 by 2. 2 power 1. 4 plus 2. Yes, which one? Oh, this one symmetrical. 1, 2, 3, 4, 5, 6, 7, 8, right? So here, no, last one. This one won't show. This one, 2 power 1, 2. Here I am directly entering into preparation of alkenes now. Preparation of alkenes. So I already told you, if you need total any geometrical isomerism, go back and watch the videos. So preparation of alkenes. So recently one JEE main question came. I already told you in our first concept which I taught in our YouTube channel, right? Ozonolysis, Lindlar's catalyst and bridge reduction. So that question came in the exam. And ozonolysis also is came. Aldol. So whatever the videos which I did, only few videos which I did, from each video one question is came. Okay, so try to follow those videos. If it is really important, then only I will do those videos, right? Otherwise I won't do. So from each video questions came. Right, so from all kinds. So actually, if you are doing hydrogen in presence of nickel or platinum or palladium, what exactly happens? We'll get alkene, and alkene further reactions takes place, we'll get alkanes. So means we can't stop that alkene level. If we want to stop the alkene level, if we want to stop alkene level, so we need to use two specific reagents. What are those? Lindlar's catalyst, reduction, hydrogen, palladium in presence of BaSO4. So quinoline is as a poison we will use. So here simply we'll get cis alkenes now. cis alkene. So lithium in presence of liquid ammonia, or we could say sodium in presence of also liquid ammonia, will get what alkenes? Trans alkenes. Trans alkenes. This reaction we call as Birch reduction. Birch reduction. So the above one we are called as Lindlar's catalyst. Lindlar's catalyst or Lindlar's reaction. Cis and trans, actually this mechanism is there, but in that mechanism it's not needed by either cis or trans, because a lot of people are confusing here. Which one is cis and which one is trans? I already told you examiner's favorite question this. Where the student is going to struck. Where the student is going to. So two confusions are there. So there they are asking the question. Particularly I already told you they'll ask this question. They asked. If you want, you can go back, and I told you the 5-star, and I made one video also based on this. So I gave you one shortcut trick. Even of course I'll explain the mechanism. Palladium presence of barium sulfate. No. So what exactly happens? So the two hydrogens will attack from the same side, but in this case, so here is the lone pairs which are producing both are opposite direction. So there in liquid ammonia we are using. I'll explain the mechanism. But particularly in case of palladium presence of barium sulfate, there is no nitrogen. Here in this case, ammonia case, nitrogen is there. Nitrogen is in which direction? Cis or trans? Trans. Obviously the product is trans. So by seeing the reagents also by default, we can identify if the nitrogen is there, trans. Of course, I'll explain the mechanism. Write it down. So above one case, here is for Lindlar's catalyst same, because this is a linear one, so no mechanism is needed. Directly they'll attach from the one side. But whereas in this case, sodium generally undergoes Na plus electron, right? Lithium or sodium. So generally I'm just taking the sodium. Alkyne CH3 C triple bond C CH3. This undergoes homolytic cleavage, homolytic cleavage. CH3 C radical, double bond C CH3 radical. Now sodium is also giving one electron to here, 2 moles if you are taking. So there is two types of products we can see. CH3 C, it is the lone pair. Okay, double bond C lone pair CH3, one possibility, and one more possibility CH3 lone pair double bond C lone pair CH3. Now let me know in these two cases which is more stable now. So this is more stable because the lone pair electron pair repulsions are there. So this is more stable. So then afterwards ammonia, liquid ammonia is there, right? It's proton donor. No? So H plus is donating automatically C, right? One side hydrogen, opposite side hydrogen, CH3. Means what? Trans product is forming. Actually, the mechanism is not needed. I told you the shortcut, that is more than enough. But so that is my responsibility to explain the mechanism. I explained. So write it down. Elimination reactions are there. For example, dehydration, dehydrohalogenation, dehalogenation. Right? In all the cases, what happens? We can prepare alkenes. So, for example, here is Sage product and Hoffman product, like a lot of things are there. So first we'll discuss, write one important, CH3CH2Cl. From using alcoholic KOH now. Alcoholic KOH. Here is aqueous KOH. Means solvent is water, it is solvent is alcohol. So what exactly happens? Both the cases KOH, KOH. So what is the product we will get? Let me know. This is important reaction, no? So aqueous KOH, no, nucleophilic substitution reaction. Write it down. Nucleophilic substitution reaction. In this case, elimination reaction. Elimination. Alcoholic KOH were called as dehydrohalogenating agent. Dehydrohalogenating agent means what? It taking one hydrogen and one chlorine. Minus HCl is going out. So we'll get alkene here. Alkene. So here we will get CH3CH2OH. Because don't confuse, that's the reason I'm both at a time I'm giving you. Alcoholic KOH, aqueous KOH. Nucleophilic substitution reaction, but not NSR. One more important thing now. For example, here is the chlorine. Imagine here I'm using alcoholic KOH. Is tertiary butoxide, O minus Na, bulky base. So bulky base, both the cases elimination reaction takes place. So first case according to Tate Jeff proper, Tate Jeff's products, it is Hoffman product. Hoffman product. So first we'll discuss what exactly the states of products means. More substituted alkene, stable alkene is forming. Which one? More stable alkene, or we could say more substituted alkene. In this case, terminal alkene is forming. So first I'll discuss alcoholic KOH, what exactly happens. First I'll write the product, of course. Here the product is like this. Here the product is like this. First write the products. So in these two cases, which is more stable? Alkene. Here is nothing but what, Nana? CH3, CH, double bond CH, CH3. Total 6 alpha hydrogens are there. Alpha hydrogens. This is alpha alpha. 3 3, 6 alpha hydrogens. Whereas in this case, only 2 alpha hydrogens. So whenever stable alkene is forming means that is Tate-Jeff product. Whenever unstable alkene, when bulky base we are using, bulky base, and even CBal cases also Hoffman product is forming. I'll explain that. So first just write it down to avoid the confusion, because they keep on asking this type of questions frequently. So means here is it is major. Here it is major. So if you are using the tertiary butoxide, right? This is bulky base. Bulk base అని రాసుకోండి. One, two, three, tertiary butoxide. So alcoholic KOH only I am giving. Write the product. Directly I am writing the product. So next one more reaction. This is also very important. Dehydration. concentrated H2SO4. Concentrated H2SO4 is a dehydrating agent. Here also I am taking the concentrated H2SO4. This is 140 degrees centigrade. This is 170 degrees centigrade. 140 plus 273 is how much? 413 Kelvin. 413 Kelvin. Here is 443 Kelvin. Sometimes both are temperatures are particularly here is important. Temperatures are particularly important. Whenever the high temperatures 170 degrees centigrade, dehydration takes place, you'll get alkenes, no? But whereas in this case, you'll get ethers. The temperature. So for the second year guys, this is important. And of course, you people are almost 11th class also going to second year, right? So that's the reason both are important. Temperature, concentrated sulfuric acid at 140 degrees centigrade, 170 degrees centigrade. Write it down. Dehydration, dehydration is coming in second year's alcohols also. In alcohols, here is carbocation. So first mechanism I will explain. CH3CH2OH. So when concentrated H2SO4, so imagine whenever carbocation is forming, carbocation is an intermediate. So rearrangements are possible, right? So first H plus is giving CH3CH2OH. Here is from H plus is coming. So this H plus, oxygen having the two lone pairs, right? It's a dark side oxygen. H plus. So then CH3, CH2, OH, this is H, positive charge. So then OH is weak leaving group, poor leaving group, whereas water is good leaving group. So water is going out. We'll get CH3, CH2 plus carbocation. So then CH2H, this is coming here, the H plus is going out. So whatever the H plus we added, that is coming out with alkene. CH2 double bond, CH2. Proton, right? H plus is nothing but proton. Protonation takes place, then पानी निकलते, जब पानी निकलते ना कार्बोकेटायन बनता, जब कार्बोकेटायन बनता ना, सो जो पानी है ना, सो पानी यहाँ पे जो पानी आके और H प्लस को लेके जाते, तो अल्कीन बनता. जब भी कार्बोकेटायन बनते ना इंटरमीडिएट, तो रीअरेंजमेंट्स हो जाएगा. डिहाइड्रेशन, यस. Whenever the acid falls on our skin, our skin is also having पानी, right, water, so dehydration takes place. Done? Completed? Chalo. Right now, so this is the homework for draft, not the homework. Right now only you have to do. Come on, do it everyone. CH3. (170 degrees centigrade). Okay. तो IIT पढ़ रहे हैं आप, नीट पढ़ रहे हैं हर्षा सिंह? Come on, write it down, the products. 7th and 8th cases, ring expansionist takes place now. So first one, so propene, obviously, no issues. I'm writing the major product only. Here, major product only I'm writing. In this case, methyl shift is takes place now. Fourth case, methyl shift is takes place. So first OH group is going out, then carbocation, methyl shift. So first OH is going out, we'll get the carbocation here. Ring expansionist takes place, 5-member ring, we'll get into 6-member ring, right? So directly I'm writing the product here. So we'll get like this. Here is also 5-membered. So try as a homework this one. So tomorrow dehalogenation, right? And deamination. So a lot of things are there. We'll discuss those are tomorrow. Okay. You guys are 11th class. That's the reason I'm just going a bit slow. Okay. Otherwise, so whatever I gave you, just practice and come back. Right, Nana?